Okay, PE2. This is our PE2. All right, so let's see. Oh, game of NIM. I see. Okay, NIM is a mathematical strategy game in which two players take turns removing objects from distinct heap or piles. Okay, so on each turn, a player must remove at least one object, so he must remove one. Okay, and may remove any number provided they all come from the same pile. Okay, you must remove at least one, but they must all be from the same pile. So you can technically remove the whole pile, right? Depending on the version being played, the goal is to either avoid taking the last or to take the last. Okay, so it depends on how you winner takes the last or loser takes the last. Okay. So in our version of NIM, we'll play using matchsticks. Well, okay, matchsticks or rocks or stone, whichever lah. Just some tokens. Okay, so they are separated into piles, lined up like this. Okay, so the game above has 3 piles of 4 sticks. So yes, 4, 6, and 8. Okay, sticks. The state of the game is represented as a vector, which it represents number of sticks in a pile. Okay, so this is 4, 6, 8. Okay, so you can just write. Okay, very good. Now, suppose everyone understand, right? It's not a very difficult thing to understand, right? This question is not, I don't think it's too difficult at this part. Okay, suppose we number the matchsticks 1 to n, right? So pile 0, pile 2. So pile 0 is here, pile 1 is here. Okay, sure. Implement the function pile vector, so the vector is a game, an integer n, and return the number of pile of the nth matchstick. So first pile is number 0, right? So nth matchstick. And you're told that n will not be more than the matchstick now. So in this thing, you'll never get a 19. Okay, so n will always be valid. Okay, either be 1 to 18. All right, so let's look at an example. If I say matchstick 5 is here, yes, it's in pile 1. Matchstick 16 is in here, it's in pile 2. Okay, so how to do this? Let's think about this first. I think to check whether the pile is there, one way you can do is to sum up, right? Sum up. I think summing up is a reasonable way. Right? So, for example, say you're looking at matchstick 8. Okay? So you start the vector, right? First, you have 4. Well, 8 is more than 4, so 8 definitely not in this pile, correct? So I have a count of 4. 8 is not in this pile. Okay, so this is pile 0. 8 is not in this pile. Then next one is 6. So if this is 6, means I will have looked at 10 matchsticks, right? Technically, by adding up, I'm actually looking at the last matchstick of the pile. So this is the pattern you observe. So the moment what I'm looking for is less than the last matchstick of the pile, and that is the pile that I want, isn't it? So if you think about it, right? So pile 0 is 4, pile 1 is 10, pile 2 is 18. Okay. So basically, I can have a loop, right? I mean, I don't know how I actually solve it, but down here, in what I will do under exam condition, this will definitely solve the question. So I start at pile 0, see what is the last matchstick. Okay, if what I'm looking for n is not less than this or less than equal, can also be equal, right? If I'm looking for 4, then I'm at pile 0. Otherwise, I go to pile 1 and all that. Okay, so let's just write the thing. Okay, so I download the code. Let me just download template. Okay. Open with code. Okay, show in folder. Open with code. Okay. Okay, so let's take a look. Pile here. So I will basically have a int p, right? Int p, p equals 0. Okay, we can do p equals 0. So we start with pile 0. Integer count equal to 0. Count should not be 0 lah. Count should be game 0, right? The count should be game 0. Okay, you start with game 0. So here's our loop, right? while n is greater than count. I mean not count, I just use the word count. If while n is greater than count, what do we want to do? Basically, we include the next pile, right? So p plus equal 1, count. Oh, no, don't plus equal p first. We want to add, do you want to add a count? Let me think. Yeah, we add p, then we count plus equal game p, right? If you think about it, okay, let's go back to the open board. So let's doodle and draw here, right? So you have 4 matchsticks. All right, so p is 0, count is 4. Okay, n says is supposed to 8. So n is bigger than count. 8 is bigger than count. Count is 4. So I want to include the next pile, right? So the next pile has 6 matchsticks. So I increase p by 1. So p becomes 1. My count increased by 6. So counts become 10 now. Okay, so n is now not more than count, right? 8 is less than equal to count. So my loop will stop. Okay, so in the end, I can just return p. Okay, so this is the pile. Okay, we work for the n case. Let's say, so check this. So we check corner case. Let's say pile 2 also got 5. Okay, so basically it's 15. So n is 15. If I come to pile 2, n will be 15, count is 15, this will still fail, right? Because n is not more than count. Okay, so this is the correct symbol to use, correct comparator to use. If n is 1, then you get 0 because minimally you must have at least 1 matchstick in pile 1, right? Okay, so count would already be more than, would at least be 1. Okay, if count is 2, okay, yeah, so this works. Okay, so this is the answer. Okay, for part A. Any questions? Any question? We'll check. No question here, right? Okay, no question on this. Okay. Okay, next one. Part B. So name is played by removing matchsticks from a pile. Okay, implement a function remove. Okay, which takes in a pile and updates by removing joysticks from a given pile. Note that when a pile is completely removed, it should be removed from the game state. Okay. So remove matchsticks from one pile. Okay, does it say anything extra? Let's see here. This is just very simple. Let's remove matchsticks from a pile. So basically the thing to take note of is just this part here, right? This thing, the split part. Okay? This split part. When we remove everything, we must make sure the pile gets removed. Okay, so let's just implement the normal one first. Okay, normal one first. Normal one is game pile minus equal n. Okay, just remove n from the game pile. Right, I think that's straightforward. So this says, does the statement, does the question say if it will be illegal? No, inputs are all valid. Okay, n is not more than the size of the pile, so you don't have to check. Okay, so just remove. Now the next part is you must decide whether the pile is 0, right? So if game pile now equals 0, my pile is now 0. I must remove that thing. Okay, so to remove, this is about vectors, right? In vector. Okay, you can very easily say vector dot, is it remove? Suddenly I can't remember the erase. Anyway, open book, right? Go to lectures, go and find vectors. Okay, so I really can't remember the name because there's so many languages, right? Different languages got different things. So look up the documentation. Where's our vectors? Here it is. Erase. Okay, erase giving iterator. So it's a erase. Erase. So it's not. Oh, sorry, it's not vector.erase. Game.erase. Erase the begin plus pow. Okay. So begin is the starting point plus pow. So we need some iterator. I think we have some. Do we have some examples here? Don't have. Where here erase begin plus 5 lah. So this is basically the code here, right? Okay, so that's all. Delete the pow and done. Okay, so 7 marks is done here already. All right. So last year's PE is 2 hours. So you just spend 15 minutes part A, part B. Then you spend the rest of the minutes to figure out how to do part C. Part C is a tricky one. Part C is a really tricky one. Okay, so minimally 7 marks, 5 marks, 12 marks. Okay, minimally you pass the PE already. Okay, if you do A and B, which is done in 15 minutes, okay, you pass your PE. Okay, so that's last year. Okay, now let's take a look at the tricky part. Okay, tricky part. Consider this variation in rules. Okay, so you don't just remove from POW. You can split POWs now. When some meshes in the middle of POWs are removed, the POW might be split. Wow, so tricky. Okay, so example, here, back to our old example again. If you remove mesh stick, 13 and 15. Which is 13 and 15? Okay. No, mesh sticks 13 through 15 are removed. So shown in part A. So okay, go back to part A. So this one. Okay, so oops. Erase. Okay, so mesh stick 13 through 15 are removed. Okay, we end up with this particular POW. So our 4, 6, 8 POW become 4, 6, 2, 3. That's what it says, right? That's what I guess. So yes, I'm right. Okay, become 4, 6, 2, 2. I think there's a typo here. Should be 4, 6, 2, 3, I think. 13 through 15 remove. I think this should be 3. Okay, I think there's a typo here. Okay. Yeah, correct. Here, 4, 6, 2, 3 is correct. So I put a typo here. 4, 6, 2, 3 is correct. Okay, so typo there. As before, if it's completely removed, it will be removed. So suppose now 11 through 12 is removed. So now we remove this. So the state becomes 2, 6, 3. Okay, correct. Okay. So mesh sticks are consecutively numbered 1 to n. Okay, across the POWs. Okay, 1 to n across the POWs. So the numbers are this way. So if the mesh stick stretches across the POWs, then the move is illegal. Nothing happens. Okay, so this is an illegal move, right? Nothing happens. Okay, if it's a legal move, then the game state will update. All right, how to figure this out? I think first thing we need to figure is whether the mesh sticks that you want to remove is in the same pile or not. Right? One easy way to check is you check the first mesh stick and the last mesh stick, whether they are in the same pile. Right? You use our pile function. If they are in different pile, then illegal move, right? Okay, so I don't know. I mean, for me, it seems that first I will check if valid, right? If it's the same pile, right? So if pile of first is not the same as pile of last, that's return, right? Do nothing, right? Illegal move. Okay. Illegal move. Okay, this is a very simple part. Okay. I think this works, right? Because pile takes in a mesh stick number. Right? So if the both piles are not the same pile, then you just delete, right? Okay. Okay, so now we dealt with the illegal move. Now we are guaranteed that the matchsticks are in the same pile. Okay, to remove. Now, how to do the split thing? What? How? I mean, you just solve one problem at a time, right? So there are some illegal move. I think so right now, I think maybe it's easier to just deal with the illegal move, right? So if you do an illegal move, you solve part of the problem. Right. Why would it not be obvious to handle the illegal move first? Yeah, why would it not be obvious? I mean, when you solve problem, you choose which is the easiest thing to solve first, and then you just deal with that, right? You handle all the easier cases first, right? So the moment you handle an easy case, this one you get a few marks already, lah. You confirm illegal move you handle, right? A few marks is in the bank already, lah. Right, so just by doing this 2 lines, okay, I think based on it, probably 2 marks is in the bank already, lah. Okay, so why would you not pick the easiest task to do and just solve it? Then you don't have to think about it anymore. Right, so minimally you already get the marks already. So you think about it, right? You check every problem, there are certain parts. So what you do is you just figure out, choose the easiest thing to do and deal with it. Because if the move is illegal, then there's no need to go and figure out which part to move, which part is that. Right? Straight away illegal, then you just return, and then that's it, right? You solve for those illegal cases. Right? So illegal cases is immediately done. Right. Now, how do you handle the split? Actually, I don't know how what my model solution is, but to handle the split, right? So now suppose we are in one pile here. Okay. So I think if the first matches this, right? Suppose if I say 5 is this. Okay. If my first matches this, then it's not a split, right? Because you will delete. Or if my last matches this, right? Then we're not going to split, correct? Okay. How do we figure this thing out? So if I think you can do the counting thing, right? Okay. So one easy way to do is this, right? If your first, is in the pile, is in one pile, and then the first -1 is in another pile. Okay, right? It's in another pile. Then you know that you are not splitting. Okay, so this is one way to check, right? Okay, so well, let's just very simply. Okay, so pretty much okay. So now basically we want to check if there's a split on the left side. Okay, check whether there's a split on the left side. Okay, to check for a split on the left side, basically if your first is more than 1. If your first is 1, then obviously there's no left split. Okay, there is no left split. If first is more than 1 and pile of first -1 is not equal to pile of first, right? It is very simple, right? Then you have a split, right? Right, because the one before you is not in a different pile, so you know that first is definitely the left hand of the pile that you want. Okay, so we're not splitting that. If we're not splitting that, how do you go and figure out how much you are left in there? Okay, so Yeah. So first, if first power first item first is 1 equal to 1 First power first item is 1, right? First power first item is whatever number it is, right? Whatever number, like, it can be 2, can be 5, right? That's the thing, right? Okay, so I mean you can have 1, 1, 1, 1 like that. Every single power is 1 So 2 is here, 1, they are in different powers. Okay, so if you are doing this, if you are splitting left and right, then then how much you are left with is just check if split left. Basically, you get many conditions to do. You check that you are splitting left. Okay, you can figure out. Okay, so suppose you're not splitting left. Suppose you are at 7. Okay, you discover you're not splitting left. So you must realize that there is two powers behind here. I think in my solution I did a lot of math. I think in my solution I did a lot of math. Basically, I did a running count. Okay, I said that this is 4 here. Then I said this is actually 10. I think I did a running count in my original solution. Okay, I did this. So with a vector of all this, okay, I can figure out that this middle power is 4 plus 1 to 10. Okay, I think I did that in my solution. Okay, but I'm trying not to do that. I'm trying to show you another way of doing it. So basically brute force way. Okay, I want to figure out how many counts are in the left part, right? So if we are not splitting, if we are not on the left hand side, then we need to split. Okay, if not on the left hand side, then left equals to 0. Let me see, left equals something. Okay, while left equals to 1, while power of first minus left equals to power of first. Okay, so this is then left plus equal 1. So basically I'm just doing a count. Okay, so first minus left. So say we are at 7. So left I say is 1. Okay, so I know that there are some meshes on the left of me. Okay, so say left is 1. So I check, is this still same part as me? Okay, if it is, become 2. Okay, is this still the same part as me? Okay, it is, then become 3. But 3 is not in the same part as me anymore. Okay, so I cannot have 3 here. So I think easiest is 0 . Okay. Okay, so while I must also consider the fact that first minus left is more than 0. Okay, so if 1, 2, 3, so let's say I'm in power 1 here. I'm in 3. So 3 minus 3 is 0. Okay, so if 3 minus 3 is 0, then I don't continue. So left minus equal 1. Okay, so this is the way I'm doing, but I see it's very complicated. So maybe you can say left equals 0, then you do a left minus 1. No, I think this is quite. Let's leave it as this. Okay, so what I'm doing is I'm counting how many matchsticks are on the left side, right? By just going down this way. Okay, so 7, 6, 5. Once I hit 4, basically left would be 3, right? So left of power of 4 is not the same as power of 7. All right? Technically, you don't have to check 7 now. You can just always check between the two powers. right? So left, yeah, I think checking between the two piles is easier. Okay, so let's just rewrite this, okay, to make things easier. So left equals to, no, actually we're going to do a count. Okay, we just leave it as this. This is our first thought. Okay, so now we have the number we want to split left. Okay, so here integer left equals to 0. Okay, so if you have nothing to split on left, then left is 0. Okay. Next one, check if anything to split on the right. Okay. If not, if last is greater than the last pile. So how to check that last is not at the end? So this method is a bit tricky because you need to know how many metrics are there at the end. All right. So last, okay, so this method is a bit tricky because we need to, what? The size, okay, you need to add up everything, okay, to figure out what is the thing at the end. Okay, so I'm beginning to think that this method of me doing this way, maybe it's a bit more troublesome. Maybe my initial idea of just figuring out where the boundaries are makes more sense. Okay, so let's abandon this approach for a while. Okay, so what I want to do now is I want to concentrate on the part I'm talking at. I'm interested in the left and rightmost number of the part. Okay, so this is what I'm interested in, right? The left and rightmost number of the part. So if I know what is the leftmost match and the rightmost match, then it's easier for me to do my comparison. Okay, so here maybe I don't talk about the split left. Okay, determine the boundaries. How to determine the boundary? Okay, wow. Okay, so let's call left and right again. Okay, left equals to game 0. Right. Order. Okay, left equal to 0 for I in while let me think of something else. If while pile of first is more than I, right? Okay. Okay, left equal 1. Okay, I at first is 0. So my pile of first, so I can reuse pile lah. If you don't want, you can just do add, but it's fine. So pile just give me which pile. So if the pile of the first, okay, is not pile 0, then basically what you will do is I plus plus. Okay, what you do is left plus equal pile of I, right? All right, so let's examine this first. So at first, left is 1. Okay, so left is 1 because I'm pointing here. Left is 1, right? 1. I is 0. If the pile of first is in pile 0, means they're equal, right? Then I will not run the loop. So left is 1, correct? Okay. If pile of first say is 1, so pile of first will return 1, which is more than 0. Okay, what I'll do is I will add left to pile whatever content. So add 1 to 4. So this will be 5. Correct. Okay, I will point to the first. Then I will become 1. If Okay, so power of first, mistake here. Okay, sorry. Power of first is 1, right? So suppose, say this 5, 6, 7, okay, is 1. This is no longer more than it's equal. Okay, so the loop will stop, right? So my left correctly holds this. Okay, how about the right? Right will just be 5 plus 10 minus 1, right? Okay, 5 plus 10 minus 1. Okay, so then my right, my right equals to left plus power of last, and power of last and power of first is the same. Okay, minus 1. Right, so now I have so now I have my boundaries left and right. I'm very happy already. So very simple with this little for loop. I established my boundaries. Okay, so let me erase all this thing. I established my boundaries left and right. Okay, so now I can go ahead and figure out how to slice the thing. Okay, so if so now my check left don't need to be so complicated, right? Check split left. If left equal to first, right? This if left equal to first, then I don't have to split left anymore. So if left is less than first, then I need to split left. Okay, so if I need to split left, then let me think which case is easier to consider. Not splitting. Not splitting is easier, man. Okay, I'm not splitting. Okay, I'm trying to figure out how to make it nice and elegant, but never mind, this is PE. Okay, so if you don't need to split left, I think easier if I be clear of what I need to do first. Okay, then end of the day, then I decide how to manipulate the data. Okay, so let's try to be clear. Check where I need to split left. So if I need to split left, so maybe here, new left and new right. Okay. So if I need, new left is 0, right? Okay, and new right is 0. Okay, so new left tells me how many, after this split, how many is on the left side, how many is on the right side. Okay, if one of them is 0, I mean I'm not splitting. Right? If both of them are 0, means I completely delete the pile. Right? So what I'm doing now is I'm gathering information here to decide what I need to do. So what I'm doing is I have this. Okay, what I'm doing is I have this. So now I'm focusing on one pile already, right? I have focused on one pile already. So here is my left. Let's use red lah. Red, easier to see on this background. Okay, so here is my left, and say my right is, I don't know, 10. Okay, so I have my left and my right. So what I'm doing is I'm going to split something here. So I'm gathering how many do I have left on this side? How many do I have left on the side? The new left, new right. Or maybe I should say remain. Okay, left remaining. Remain on left, remain on right. Okay, so the remainder. Okay, so here, if after I figure out how many is there, if one of them is 0, then it just means there's no split. Right? There's no split. If both of them are 0, it means this whole thing must delete away. Correct or not? Right? If there's no more thing at the side, this whole chunk delete away. So I have sort of two different outcome, right? Three different outcome. One is split. One is no split. One is completely delete. And so now my next step is to figure out what's this left and right. So very simple. I can figure out what is this left and right by checking if left is less than first, then remain left equals to first minus left. Okay, let's check. So say I'm doing 7. I know that here must be 2, right? 5 and 6. So 7 minus 5 is 2. So correct. Okay. In fact, regardless if this is 5 and 5, and minus also will correct, right? So actually, this one I can check split left. Integer remain left is just first minus left, right? Correct. So this would, if I'm splitting at 5, 5 is 5, so 5 minus 5 is 0. So this line will just tell me immediately how many I have left. Okay, so I don't have to put condition. Okay, so I think similarly for right. Okay. Okay, so remain right is just, okay, your last, say last is 10 minus whatever this is. If this is 8. Okay, so 10 minus 8. Okay, so similarly, this is your last minus right. Sorry, right minus last. Okay, so be sure to take note. Okay, so this is my left, this is my first, this is my last, this is my right. Okay. So now I know I have information on what is here, what is here. Okay, so now I can do my if condition. If remain left equals 0 or remain right. Oh no, let's not do the or first. Let's do the easiest case. Both are 0. Okay, this delete. Delete. Okay, where is it? Remove. Okay, so that's the, we can use remove. Or we can just use erase. Okay, so let's just use erase lah. Okay, let's use erase. Erase game begin pile of I, right? Pile of first. I mean pile of anybody. Okay, you just delete that. Okay. All right. Okay, so this will just delete. Okay, I mean you want to use remove also can remove from the pile and just whatever number is there. Okay. Okay. Else. We need else. Okay, because now I want to check what happens if, okay, the next easiest one is don't split, right? So if remain left equals 0 or remain right equals 0, okay, very simply, I just remove. So how to remove? Oops. Okay, sorry. I keep using power. So maybe I will create a nice integer here. Says integer p equals to power of first. Okay, p is power of first, right? So power is here. I can't use power because this is a power. So if p equal power, so I can replace all the power with p, right? P. Power. So this is also p. Say power of first, power of last is p. Okay, p. But p is such a bad thing to use. Okay, he used power, so it's interesting. Okay, so never mind. I use p. Okay, so plus p. Okay, so if remain left equals 0 or remain right equals 0, why no highlighting? So odd. Okay, doesn't matter. If any of them is 0, then I just call remove, right? Remove game. I mean, I can do call remove if I want to, or I just update. How many am I removing? I am removing last minus first plus 1. Right? Last minus first plus 1. So again, check. That's a check. So if I'm removing, say 7, or say 5 and 7, I'm removing actually 3, right? So 7 minus 5 equals to 2, so I must plus 1. Okay, so I'm removing 5, 6, and 7. So last minus, okay. So this works whether left or right. I mean, I really don't care at this point because at least one is 0. At least one is 0 means either left or right. Cannot be. Actually, if you think about it, remove will nicely delete the game, right? Remove and nicely delete away the pile if I remove everything, isn't it? So I don't even need to bother having this thing here, right? So to make it cleaner, right? So frankly, just like that, if anyone is 0, this works, right? Last minus first plus 1, if it's the whole pile, it'll be the whole thing. So let's test. Okay, test again. 5 is here, 10 is here, right? Suppose I really want to delete. Last is 10, this is 5, right? So down here, my check here will tell me both are 0, correct? So 10 minus 5 plus 1 is 6. So yes, there's actually 6 in here because, really got 6 in here. Okay, so this remove from P6 will nicely remove the pile. So I don't have to deal with erase. So the no split one is magically handled. So what we need to handle now is the split, right? So you realize, and as I go down, my code becomes cleaner and easier to understand, right? So my first thought is not straight away have this clean code that you see, right? We usually have certain code. Okay, so what I'm showing you is actually more the thought process, right? So like I said, this part here, this part C is really, really quite tough. So the assumption is part A and B, you finish in half an hour tops. Then now you have 1.5 hours to work on part C. Okay, so you will probably go down the wrong path initially, but you slowly, as you work the problem, you figure out the easier way to do things. And so now we have cleaned our code up to this stage. Okay, so now we are here at this stage. So how do we do the split? Actually, the split pretty much straightforward, right? I just so technically this is pile 0, pile 1, pile 2, right? I can change pile 1. Okay, what does insert do? If I insert into 1, where does it go? Okay, so let's say I have 4, okay, 4, this is 6, right? 4, 6, 5, 4, 6, 5. If I insert into pile 1, okay, say I insert 2 into pile 1, does it become 4, 2, 6, 5 or 4, 6, 2, 5? Where does the insertion go? Okay, so I suspect it's this one. Then you go and check lecture notes. Lecture notes say, what does lecture notes say? Lecture notes says insert into index 5, everything gets pushed down. So if I insert into pile 1, everything gets pushed down. Okay, so before everything gets pushed down, I update this to show my right side. So game P equals to remain right. Okay, remain right. Then I insert into plus P. How do I insert in? I insert remain left. Right, so I already calculated what's on the left, what's on the right. So this is basically the split. Okay, and I think we are done. Okay, so we are done. Okay, quite exhausting, this thing. I also took quite a bit of time, right, to talk through, and I think I took half an hour, right? There about half an hour-ish, I think. So if you times 2 times 3, you have 1.5 hours to do this. This is a 2-hour paper. Again, part C is not, say, very trivial. I mean, it's not trivial, really quite difficult to do. Minimally, you should be able to score 12 marks for A, B, and then you can get the first case right? Invalid pile, you straight away return. I'm not sure what the grading scheme is. You can check out the grading scheme. I even post the grading scheme on cosmology. So I myself forgot what the grading scheme was. So let's check out the grading scheme. Okay, let's see the grading scheme. So messy. Okay. Let's see the grading scheme. So grading scheme says part B, invalid move. Oh, okay, 1 point. Wow, I have 1 point correct already. I locate the correct pile to modify. Okay, so this is basically not too bad. So you can find the correct pile to modify, you plus 2 marks already. Okay, so you get 3 to 8 marks based on this. So you can split a pile to, okay, so minimally, okay, there's some stuff here. 1 mark doesn't update the game, bad stuff. 1 mark if the first equal last, but work correctly if first less than last. First equal. Yeah, so you can definitely do first equal to last, right? Our code works quite nicely. So let's test. So does our code work? Let's be more sure that our code works for most situations. So I think the most extreme case would be, say the entire pile is 1, right? The entire pile is also 1, 1, 1, then 1 here, then 1, 1, 1, right? Then you're removing, so this is 1, 2, 3, 4, 5. So you have to split 4, 4, right? You split 4, 4. So technically 4, 4 should disappear. Right? So we check. This is valid, okay? Because both numbers are 4, first and last are the same. So confirm is valid. All right. Check the left boundary. So left equal to 1, while power of 4 is 1. So it will move left plus 3. This is 3. Okay, so 1 plus 4, left will be 4. So yes, left will be 4, right will also be 4. Okay. Left is 4 plus P. What's P? Yeah, but the power number. So left is 4, 4 plus 1 is 5, 5 minus 1 is 4. Yeah, so left, right, first, last, all 4. Okay, so this split will just be 0, right? 0 left, 0 right. Okay, so as long as one of them is 0, okay, we'll call this last minus first. 0 minus 0 is 0 plus 1, so remove 1. Yeah, so remove 1 from pile 1. So we assume remove works. Okay, even in cosmology, this part C is marked in isolation, right? We assume if we use the functions pile and remove, we will assume that they are working 100%. In fact, in cosmology, okay, this time around you're not using cosmology, you're submitting on exemplify. Okay? But we assume that using these functions, okay, it will work. Okay, we don't use your buggy remove. That means if you commit some minor mistakes or some mistake in remove or pile, it will not affect your question 2C. That's why I encourage you to call remove, but don't go and try to erase. In case your logic of erasing may be wrong. If you go and call erase here and you still apply the wrong logic, then I cannot help you lah. You have wrong logic here. But if you call remove, right, we assume the remove works. Right? So even if you're up here, your remove, maybe here, up here, your remove has some problem. Okay, we will not use this remove. Okay, we will use what the remove is supposed to work. Okay, work 100%. Okay, so that way you don't get error carried forward in that sense. Okay, because you clearly say I intend to use remove. But if you go and put, you go and do you go and replace this with the remove code. Technically, I can't guess your intention, right? I can say, oh, you are not doing it correctly here, so I cannot assume that it is like error carried forward in that sense. You get what I mean? So if I use remove here, I use power here. Okay, so this one basically is not my job lah. The functions above it should be correct. So yes, this will definitely work. Okay. Yeah. So I think this code is correct. Any problems or question? Okay. So last semester's code quite tricky lah. This semester I think we really have 1.5 hours. Okay. So it should not be as tricky as this. This is really quite tricky code. Okay. But again, the part A, part B is good enough for you to score 12 marks, which is already passed. Okay, so you part A, part B, you can do it. Okay, you will pass the PE, no issue. This part C is for those who can score and do well. Okay, for this PE. Okay, any questions? Any questions?